So we're gonna be solving inequalities today. So some inequalities are gonna be super simple. You're gonna remember this from even Algebra 1. So we're gonna review some very, very basic ones. Then we're gonna do some things that we did in Algebra 2 with critical values. Do you guys remember critical values? Yeah. Testing in each interval, yeah. And then we're gonna do something with like polynomials, right, less than or greater than 0. So it's gonna be a little bit tougher. Okay. So we're gonna kind of start with step 1, step 2. It's gonna get a little bit harder. All right, so solve the following inequality. So let's start out super simple. So if I have 6x plus 6 is less than 12x minus 20, we solve this. We can subtract the 12x over, or you could add or subtract the 6x. It doesn't matter. We subtract the 6. We divide by a negative 6. What do we do when we do that? Yeah, we flip the inequality sign. I always call that the red flag rule. So we do x is greater than, yeah, you want to circle it. So we get x is greater than 26 over 6, which is really 13 over 3. All right, so when we put this on on a number line, we have 13 over 3, and we want everything greater than. So we're going to do an open circle because we didn't say greater than or equal to, it's just greater than, and then on. Okay, so the way we write our solution is going to be 13 over 3 to infinity. We all remember those, right? Easy. Okay, so the same thing for this one. So I can subtract the 4x over. I like for my x to be on the left. I'm picky. So I would get negative 3x plus 9 is greater than or equal to 27. Subtract the 9. Divide by negative 3. Again, flip the sign. So we get x is less than or equal to negative 6. So we have a filled in circle and everything to the left. So it's going to be negative infinity to negative 6 and then a bracket. Okay, so even if you didn't go here last year, do you know this? You've seen this before? You're confident that you can do these ones. All right, so yes?
So number 1, why was there parentheses that had a bracket on 13 over 3?
There was a parenthesis on 13 over 3 because it was open. We didn't actually include 13 over 3. And then it's a bracket. Yeah, I always think of this as being an equal sign. I don't know. It's kind of a silly way to remember it. But. All right, so on ones where we have like something with x sandwiched in between, okay? What we can do is we can add 5, but we're going to add it to all 3 locations. So we're going to have 9 is less than 3x, which is less than or equal to 23. And we want just x in the middle. So now we're going to divide by 3. So we get 3 is less than or less than x, which is less than or equal to 23 over 3. So what that means is that we have 2 inequalities, really. We have x is bigger than 3. Do you guys see that? Think of the alligator thing that you probably learned in elementary school. The bigger number is eaten. All right, and then x is less than or equal to 23 over 3. But the easiest way to think of it is that x is sandwiched between those, right? So on the number line, you're going to have everything between 3 and 23 over 3 shaded. And then for our endpoints, 3 cannot be equal to x, but 23 over 3 can be. It's going to look like that. So our answer is going to be parentheses 3 to 23 over 3, and then a bracket. Okay. And then number 4 gets kind of tricky because now we don't just have x's in the middle. We actually have x's on the right side of the inequality as well. Does that make sense? So whenever that happens, you actually do have to break it into 2. Okay, so the first inequality that we're going to have is going to be 2 is less than 3x plus 5. And the second inequality we have is going to be 3x plus 5 is less than or equal to 2x plus 11. And in between them, we put the word and, because we need for both of those inequalities to be true at the end. We want the left and the right to be true. Jason, you with me? All right, so we're going to go ahead and subtract 2, subtract 5. So we get 3x is less, hang on, I don't know why I'm doing that. Subtract 5. So we do minus 5, minus 5. So I'm going to get negative 3 is less than 3x, divide by 3, divide by 3. So I get x is greater than 1. Do you guys see? I'm reading that. X is greater than negative 1. All right, and then I have, let's see, so 3x is less than or equal to 2x plus 6. So x is less than or equal to 6. So we need both of those to be true. So we need an and between them. All right, so everything greater than -1, but also less than or equal to 6. So in the first class, they were saying, wait, does that mean the arrow goes in both directions? It kind of does. It's like this first one is everything from here over, and the second one is everything from here over, but you need where both are true. It's like where they overlap. So it ends up being in the middle, yeah. So if you want to kind of shortcut it and just write, or just shade the part in the middle, that's fine. So it's going to be parentheses -1 to 6 bracket. All right, there we go. Make sense? All right, next up. All right, so we're going to get a little bit harder. So this is kind of, level 2. So it says, if we have a more complicated inequality, such as x squared minus 3x is greater than 4, then we actually need to use something called critical values. Okay, these are the numbers that make x squared minus 3x minus 4 equal to 0. So we're going to go ahead and start out with our x squared minus 3x is greater than 4. And we're going to subtract over the 4, and we factor. So we have x minus 4 and x plus 1. So we get x equals 4, and we get x equals -1. Okay, these are what we refer to as critical values. All right, so these are the numbers that we put on a number line. Okay, and then we test in each interval. So that's where I usually put like test points, and I would put the factored form x minus 4 and x plus 1 here. And then I would test in each interval. So something on the left of -1 would be like -2, right? Something in between -1 and 4 would be like 0. And something on the right would be like 5. Okay, so we're going to use each test point. So we're going to do -2, 0, and 5. And really, you can plug them in and get numbers, but the easiest thing to do is just think about their sign. We want things that are greater than 0 in the end. We want numbers that are positive in the end. So when I plug in -2, I end up getting a negative number times a negative number, which is a positive number. And when I plug in 0, I end up getting 0 minus 4 is a negative number. 0 plus 1 is a positive number. Negative times positive is negative. And when I plug in 5, I get positive and a positive, which do multiply to be a positive. Okay, so we want the numbers that are positive in the end, so we want on the left side and the right side. What about the endpoints? -1 and 4? They're open, right? Because we didn't say equal to 0, we just said greater than 0. So our answer should be -infinity to -1, parentheses, union 4 to infinity. Like that. Non-interval notation, it would be x is less than -1 or x is greater than 4. Personally, I think it's easier with interval notation. Remembering the or versus the and all that can be hard. All right, now the easiest thing to do, now that you guys are in pre-calc, I'm going to show you something that I didn't show you last year, and you're going to hate that I didn't show you last year. It's very easy. You actually don't have to test points. Okay, if you know the shape of graphs, you are fine. But last year in Algebra 2, you were not very good at parent functions. Sorry. Many of you didn't know what certain graphs looked like. All right, so let's think about it. If I have x squared minus 3x minus 4, what shape is that? It's a parabola. Where are its x-intercepts? We actually found them. Yeah, it crosses at 4, and it crosses at -1. Does this parabola go up, or does it go down? It goes up. So a rough sketch of it would look something like this, right? So where is the parabola greater than 0? Where is it above the x-axis? Here and here, right? That's all you need. It's saying x values that are less than -1 and x values that are greater than 4. So basically, instead of doing all of this stuff, you can ignore it. You don't have to do that. All you have to think about is, oh, well, these are my x-intercepts, and it's a parabola that's going up. So where would it be positive? Here and here. Does that make sense? So if you have that mastered, you can save yourself a little bit of time with these things. All right. So let's do, so it says steps to solving a nonlinear inequality. So get the polynomial on one side of the inequality sign, find all of the zeros, write the zeros on the number line in the order that they should be in. The spaces between the critical numbers are called test intervals. So you want to pick a number in those test intervals. Test them in the original inequality or in its factored form. Factored form is usually easier. If you get a positive number, write plus above. If you get a negative number, write minus above. Decide if your solution should be positive or if it should be negative, right? If it's positive, you want to shade all the places where you had plus. If it's negative, shade all the places where you had minus. Yeah, if it's equal to, then you fill them in, right? All right, so here we go. So we have x squared minus 3x minus 18. So we're going to factor. So we did these in algebra 2. So we factor into x minus 6 and x plus 3. Right? So we get critical values of 6 and negative 3. So we put negative 3 and then 6 on the number line. We test in each location. So I could test negative 4, I could test 0, I could test 7. Or I can think about the shape. What is it? It's a parabola. Those are the x-intercepts that we just found. It goes upwards. So if we have a parabola that looks like this, we're trying to find where it's less than or equal to 0. Where it's negative, right? Or below the axis. So where is it below? Between negative 3 and 6. So we fill in here and here. So our answer should be bracket negative 3 to 6. That's it. Easy, right? All right, next one. So I'm going to get everything on one side. So I'm going to have x squared minus 3x minus 4. This is almost exactly what I did before. I factor. I get x equals 4 and x equals negative 1. So I put negative 1 and then 4 on my number line. It's a parabola, an upwards parabola. Usually it is going to be an upwards parabola if you, put everything on the correct side. If you need to divide by a negative, you can, right? If you had like a negative x squared, divide by negative 1 everywhere. Just don't forget to flip your sign. All right, so it's an upwards parabola. Where is it going to be less than 0 then? Think about it. Between where? Negative 1 and 4. So we do open, negative 1 to 4, open. So parentheses, negative 1 to 4. Easy? We like this? Yeah. So those are the types of things that you guys did last year. All right, let's move on to, we'll do number 4. So it says determine the value of the variable for which the expression is defined as a real number. So maybe it's just phrased a different way. What this is saying is basically find the domain if this is our function. F of x equals the square root of x squared plus 5x plus 6. That's what it's saying. Where is it defined? Okay, so what can we not have under square roots? Can't have negative numbers. So what we want to say is that this part that's under there has to be positive or 0. Can't be negative. All right, so we're going to say x squared plus 5x plus 6 has to be greater than or equal to 0. You actually can take the square root of 0. I've seen some of you guys do that on your homework where you say, oh, it doesn't work. No solution, undefined. Right? Square root of 0 is 0. All right, so we factor. We get x plus 2 and x plus 3. So we get critical values of negative 2 and negative 3. So we put negative 3 first and then negative 2, right? Think about the number line. Going towards 0. All right, you could test in each interval. Do you guys like the method I showed you with the parabolas? Give an upwards parabola. Give an upwards parabola. Where is it greater than or equal to 0? On the ends, right? So you're going to have open there. Well, no, closed, actually, because we could have negative 3 and closed. So that means our answer is negative infinity to negative 3, bracket, union, bracket, negative 2 to infinity. So what we really just found, we found the domain of f of x equals the square root of x squared plus 5x plus 6. We're saying we can have almost every single number except for the numbers between negative 3 and negative 2. Yes?
I thought when you said that on the square root of 0 is 0, that wouldn't that mean that 0 times 0 would be 0, so 0 divided by 0 would still be 0?
No, you're using bad logic. Can't do that. But I understand what you're saying. This is how you can prove that like 2 is equal to 1 and doing some proof. 2 equals 1. Do not divide by 0 in part of your proof. That's bad. All right, here we go. So number 5. So what's different about number 5 that you notice?
It's got a lot. That has a cube.
It has an x cubed, right? So now we're going to do other types of polynomials. So maybe you have to use synthetic division to factor your polynomials, right? This is welcome to pre-calc. It's a little bit harder. You learn the basics, and then we expand on it, right? So we're going to add the 48 over. So we're going to have 2x cubed minus 3x squared minus 32x plus 48. We want greater than 0. It has 4 terms. Can we factor by grouping?
Yeah.
We actually can, yeah. So we're going to split the middle. And when we do that, we pull out an x squared, and we're left with 2x minus 3. We know we want a 2x minus 3 over here, so what number can we pull out? Negative 16, right? 16 times 3 is 48. That might not be one that you knew, but you at least knew 16 times 2 is 32, right? So we pull out the 2x minus 3, and we're left with x squared minus 16. Difference of 2 squares, right? So it factors further. X plus 4, x minus 4. And we set each one equal to 0 to find the critical values. So we have x equals 3 over 2, x equals negative 4, x equals 4. So we put negative 4 first, then 3 over 2, and then 4. Okay, so you could do the test points, right? I could do a little table, and I could do test points of negative 5 and 0 and 2 and 5, right? And if I do those, it doesn't take very long, right? If I plug in negative 5, I get a negative times a negative times a negative, which is a negative. If I plug in 0, I get a negative times a positive times a negative. It's a positive. If I plug in 2, I get a positive times a positive times a negative. It's a negative. And if I plug in 5, I get a positive times positive times positive, which is a positive. So it did not take very long to do that. Or you can still use the shape of the graph. If you have something that's 2x cubed minus 3x squared minus 32x plus 48, what do you think it looks like? The squiggle thing, right? This thing, right? So what's going to happen is if you graph it, these are the x-intercepts. It's where it's crossing the x-axis. So you're going up, you're coming down, and then you're going back up. So we're saying, where is it greater than 0? Negative 4 to negative 3, or to 3 over 2. What am I saying? Did you say that? Negative 4 to 3 over 2. Not filled in though, right? Open. So negative 4 to 3 over 2. And then 4 to infinity. Were you going to tell me the wrong thing and then try to get a bonus point? Sneaky. All right. So negative 4 to 3 over 2, and then 4 to infinity. So that's your answer. So negative 4 to 3 over 2, union 4 to infinity. Do you see how it works? So polynomials are just like what we just did, except there's going to be one more 0, one more critical value. Sometimes you might have something weird, though. Sometimes you might have like multiplicity, where there's only 2 zeros, and you're like, oh, but it's a cubic function. Then I would probably just do the test points, right? Because maybe it goes through, and then it comes back up and touches. Right? Then it gets a little bit tricky. So if you get confused, always resort back to the test points. Okay? Same for parabolas. Like you could actually have a parabola that comes down and touches. So it's always positive or 0. All right. So the next one. These are the kind of the tricky ones. So I have x plus 6 all over x plus 1 minus 2 is less than 0. Okay, so what everybody always tries to do on these is they try to, and do this, I'm going to write it, but don't write it. They try to add the 2 over, and then they try to multiply by x minus 1 to the other side. Okay, so they get x plus 6 is less than 2x minus 2. But the thing that is wrong with that is that we have no idea whether x is a positive or a negative number. If x is like negative 5, then the denominator is negative 6. And what happens when I multiply both sides by negative 6? I have to flip my sign. Does that make sense? So when you do that, you're actually making kind of a big mistake, right? We don't want to do that. Okay, we also don't want to just set it equal and then solve it and just say, oh, well, my critical value at least is x equals 8, right? There's actually more than one critical value. Okay, so the way that you should really do these problems is you should always get common denominators. So write yourself a note, get common denominators. And you should always have 0 on the other side. So get everything on one side and get common denominators to combine. All right, so what I'm going to do is I'm going to do x plus 6 over x plus 1, and then I'm going to have minus 2, and And I'm going to multiply the 2 by x plus 1 over x plus 1. Okay, so I didn't change the 2. I multiplied by the same thing on the top and the bottom. So I get x plus 6 minus 2x minus 2 all over x plus 1 is less than 0. So I get negative x plus 4 all over x plus 1 is less than 0. Okay, and when you have fractions, you actually have 2 critical values, at least 2 critical values. You have critical values that come from the numerator and critical values that come from the denominator. Okay, so what you're going to do is you're going to set the numerator equal to 0 and the denominator equal to 0. Because think about it, if I plug in numbers that are, like if I have x values that are less than -1, like -2, I'm dividing by a negative, so when I multiply that negative over, it flips my sign. Do you guys understand that? But if I have like x equals 3, it's not flipping my sign. So see why that -1 is important? It's kind of the changing point on whether your denominator is positive or negative. Okay, so we want to set both equal to 0. Okay, so I'm going to have negative x plus 4 equals 0, and I'm going to have x plus 1 is equal to 0 as well. So I get x equals 4, and I get x equals -1. I put both of those on my number line. For these ones, unless you know the shape of the rational function, so do you guys know the shape of what y equals negative x plus 4 all over x plus 1 looks like? No, probably not. We did it in the last section, but it's a lot of work to find it, right? There's a lot of like vertical asymptote, horizontal asymptote. We don't want to do all that. So the best thing to do on these rational ones is to test points. Okay, so we want to test -2, 0, and 5. So a number in each area. So when I'm testing -2, I'm testing in this fraction, negative x plus 4 all over x plus 1. What do I get? -2, when I plug it in, I get 2 plus 4 is 6 all over -1. Is it positive or negative? I get a positive number on top over a negative number on the bottom. It's negative. How about 0? When I plug that in, what do I get? 4 on top, 1 on bottom. It's positive. What about 5? I get a positive number, no, negative number on top, right? Negative 5 plus 4 is negative. All over a positive. Negative over positive is negative. Okay, it's not always going to alternate, so don't assume it alternates. All right, so I get negative, positive, negative, and I want less than 0. I want negatives. So I'm going to have this. Now, in this case, both of them are open anyway. But be careful, because if I had less than or equal to 0 for all of these different things, only one of those critical values is closed. Both of them are not. Think about it. If you plug in -1 into our fraction, do we get 0? If I plug in -1? No, I get undefined, right? I get a 0 on the denominator. Do you guys understand what I'm saying? So I don't, that you only say with the numerator would be filled in. The denominator would be open. Okay. All right, so yeah, so interval notation, -infinity to -1, parentheses 4 to infinity. So let's try this one. So same idea, but we don't have a 0 this time. Okay, so we're going to subtract the 5 over, so I'm going to have 2 minus x all over x plus 4. And I'm going to subtract the 5 over, and I know I need a common denominator, so I'm going to multiply by x plus 4 over x plus 4. So I have greater than or equal to 0. So I subtract it over. So the top becomes 2 minus x minus 5x minus 20 all over x plus 4. So we get negative 6x minus 18 all over x plus 4. So we set our numerator equal to 0 and our denominator equal to 0. So when we do that, we get x equals -3, and we get x equals -4. See how I got that? So I put -4 first, and then -3. All right, so then I'm going to test each interval. So I'm going to plug in -5, -3.5, and 0. So when I plug in negative 5, I get negative 6 times negative 5 is 30. Minus 18 is positive. All over a negative number is negative. When I test negative 3.5, negative 6 times negative 3.5, is it bigger than 18? Yeah, it's bigger than 18. So it's positive on top. All over positive. So positive. And when I try 0, I get negative 18 over 4, which is negative. We want greater than or equal to 0, so we want in the middle. So right here. So it was negative, positive, negative. All right, but what about my endpoints? Which one is filled in and which one is open? Yeah, the open has to be the denominator, because the denominator, that negative 4 doesn't make it equal to 0. It makes it undefined if you plug it in to check. But negative 3, if you plug that in to check, you do get 0. Okay, so that's the filled in one. So it's going to be parentheses, negative 4 to 3, or negative 3. And then a bracket. Does that make sense? All right, and then really quickly on the last one, I'm not going to do the whole thing for the last one, but I'm going to remind you how to get common denominators. So you're going to have 2 minus x, and then you're going to have x squared minus 4x minus 5, and you're going to subtract the 1 over x minus 5 over. So do you guys see when you factor x squared minus 4x minus 5, what do you get? X minus 5 times x plus 1. So how do I get common denominators with the other one? I multiply on the top and the bottom by x plus 1. That's the thing that's missing. Does that make sense? So you would have 2 minus x minus 1 times x plus 1. And then it would be times x minus 5, or over x minus 5 times x plus 1. You see, I kind of combined 2 steps there. I multiplied the second item, the 1 over x minus 5. I multiplied it by x plus 1 over x plus 1. And then you'd have greater than 0. So then you could continue. I guess it doesn't take that long. And leave that bottom factored, because you're going to have to find when it's equal to 0 anyway. So what do we get? So 1 minus 2x, and then the same denominator. So you would end up having 3 critical values. So you get 2 from the denominator. So those ones would both have open circles on them. So you'd have 5 and negative 1 as critical values. And then you'd also have what number? You set the numerator equal to 0? Can you do that in their head? 1/2. So you have 1/2, and then you have 5, and you have negative 1, and you would test in each location. Does that make sense? How to finish that out? Okay. All right, I'm going to pass. Well, I guess your homework is in the book, actually.